ARM big.LITTLE is a heterogeneous computing architecture developed by ARM Holdings, coupling relatively slower, low-power processor cores, little, with relatively more powerful and power-hungry ones, big. Typically, only one side or the other will be active at once, but since all cores have access to the same memory areas, workload can be swapped from big to little and back on the fly. The intention is to create a multi-core processor that can adjust better to dynamic computing needs and use less power than clock scaling alone. ARM's marketing material promises up to a 75% savings in power usage for some activities. In October 2011, big.LITTLE was announced along with the Cortex-A7, which was designed to be architecturally compatible with the Cortex-A15. In October 2012, ARM announced the Cortex-A53 and Cortex-A57, ARM8A, cores, which are also compatible with each other to allow their use in a big.LITTLE chip. ARM later announced the Cortex-A12 at Computex 2013, followed by the Cortex-A17 in February 2014. Both can also be paired in a big.LITTLE configuration with the Cortex-A7. The clustered model approach is the first and simplest implementation, arranging the processor into identically sized clusters of big or little cores. The operating system scheduler can only see one cluster at a time. When the load on the whole processor changes between low and high, the system transitions to the other cluster. All relevant data is then passed through the common L2 cache. The first core cluster is powered off and the other one is activated. A cache coherent interconnect, CCI, is used. This model has been implemented in the Samsung Exynos 5 Octa 5410.